Okay. Have you ever watched the Formula One
Yes, miss.
in Singapore? Yeah. What do you think about the characteristic of the racing car?
Really fast and stable.
Very fast and stable. Yeah. Why the racing car uh, can very fast and stable? What do you think? Can you compare the body of the racing car with another vehicles on the road?
Yes, miss.
Yeah. What do you think?
The racing car is more flat than the other.
Yeah, more flat than the other. More flat than truck. Yeah, more flat than another car. Yeah, it's related to the our previous lessons. Yeah, related to the stability. Yeah, and Andy, Andy or Adrian?
Andy, miss.
Andy said very very flat. Yeah, it's and stable, very stable and very fast. Yeah, it's related to our previous lesson about the center of gravity. Yeah. We will learn about the stability today. Yeah, we can see the this racing car have very low wide base and low center of gravity. For example, if we try to find the center of gravity, it's very low. Center of gravity, very low. Mm. Yeah, you can compare it with truck. Will be different. Yeah, let's learn about the stability. So topic 5.4. Okay, this is the learning outcome. At the end of the lesson, you should be able to describe relationship between the position of the center of gravity of an object and its stability. Okay. Can you put this in order of stability? Which one is the most stable?
D, miss.
D. What next?
B
B. And
and
then
C.
A and C. Okay, let me see. Okay. Yeah, let us consider a book. Yeah, it has six face. Yeah, two broad and four narrow face. Yeah, suppose we make it stand upright on one of its narrow face. Hmm. Yeah, book standing on one of its narrow surface is unstable. Why? For example, if we give it a slight push, yeah, what would happen if we give it a slight push? What will happen with this book?
Paul.
Yeah, the book will topple. And what do you think? Yeah, if we lay the book flat on one of the broad face and then give it a slight push, what will happen with this book? This book will not topple, but it will stay on in its original positions. We can say that this position is is stable. Yeah, a book lying flat on its broad surface is stable. Okay, this is the application of stability on daily life. Yeah, such as football also, surfing, circus. Yeah, is the application of stability on daily life. Yeah, what is stability? The stability of an object is a measure of its ability to return to its original position after it is slightly displaced. Okay. For an object to start rotating, yeah, it needs to have unbalanced moment acting on it. Yeah, for example, this is the stable object. Yeah, W is the symbol. What is the W? W is length of actions of its wake. Yeah, this is the line of actions. Yeah, from its wake. And then we can see the red color is the center of gravity. Center of gravity. Is the center of gravity. And then this is the line from its wake. The line of action from its wake, the W. So, yeah, what would happen? Yeah, when we change, yeah, the pivot. This is the pivot, and we change the pivots. What would happen with this object to make it back into its positions, to make it more stable? Yeah, it needs to have an unbalanced moment. Yeah, it's why it rotates clockwise. Rotate clockwise to make it change into the first positions. To make it change into its first positions. And yeah, for the next object, yeah, to make it balance, yeah, it will rotate anti-clockwise. Because these positions, yeah, when the pivot here, yeah, the object is unstable. So we need to have an unbalanced moment acting on it. Rotate anti-clockwise. Yeah, and then for examples, yeah, we can use the cone. Yeah, this is the stable equilibrium. The cone stable. This is the condition before being titled. And this is the condition after being titled. Yeah, R is the contact force. R contact force. W is the length of action of its wake. Line of actions of its wake. Okay, let's we identify, yeah, its center of gravity. Yeah, this is the center of gravity. The black color is center of gravity. The center of gravity. Yeah, what do you think about the center of gravity? Yeah, let's compare the center of gravity. What do you think about this center of gravity? Rises or falls the center of gravity? Yeah, after being titled, what do you think about the center of gravity? Rise, rise, rise. The center of gravity rise before returning to its original height. And then next, yeah, let's we identify the lines of actions. The W. What do you think about the line of actions? This is the base of the object or the cone. What do you think about the W, the lines of actions, yeah, from its wake? Inside or outside the base area? Is it inside or outside? Outside the base area is inside. Inside the base area. This is the base area. Is inside the base area. And then last, yeah, because the center of gravity rise and the line of actions inside the base area. Okay, let's check the moment that need by this object to go to its uh, original way, original hex. Yeah, how about the moments anti-clockwise or clockwise? How about the moments? Yeah, we can see from the arrow. Yeah, the moment is anti-clockwise. Yeah, it is anti-clockwise to make it balance and then go back into its first conditions. Yeah, anti-clockwise, anti-clockwise moment. Yeah, but the point of contact C cause the cone to return to its original positions. Yeah, we can see, yeah, when the W or line of action from its wake inlined, and then the center of gravity rise, and then, for example, anti-clockwise. Yeah, this is the stable equilibriums. Next, about the unstable equilibriums. Okay, this is the condition before. This condition after. Yeah, before that and after that. Yeah, what do you think about the, yeah, let's recheck. This is the unstable equilibriums. Yeah, what do you think about the center of gravity? Yeah, is rise or falls, the center of gravity falls and continue to fall further. And the next, yeah, about the length of actions of its wake from the base. Yeah, this is the base. This is the base. This is the base from the cone. Then you can see this is the W line of actions of its wake lies outside outside the base area of the cone. Yeah, it's why. Yeah, let's check about the moment. The moment is clockwise. The clockwise moment of its wake about the point of contact C causes the toppling. Yeah, it's unstable equilibriums. And then next, neutral equilibriums. Yeah, this neutral equilibriums. Okay, how about the center of gravity? Yeah, this before, this after. This the we cannot see. Yeah, neither falls or rise. Neither rise or fall. It remains at the same level. This is the level of center of gravity in the same levels above the surface supporting it. Yeah, next, the length. How about the length of actions? Yeah, this length of actions. And then the contact force, R is contact force. The length of action and contact force is in line. The contact force is in line with the wake length. We also can conclude that concise. Yeah, because there is no clockwise or anti-clockwise moments. Yeah, it's why the total moments is 0. Yeah, it stay on these positions and not change the positions. Yeah, that's why we can call it as neutral equilibriums. Okay, neutral equilibriums. And then go back into our starting questions. Yeah. Yeah, what is the how about the stability from this object? Okay, let's we discuss about it. Yeah, an object become unstable, yeah, when its center of gravity falls outside. Okay, this is the center of gravity. And it is the base. This is the base. You can see the base. Yeah, which one is the widest base? Yeah, this is the wider. Yeah, this Batman's wider than, yeah, this man's, and this man's wider than this woman's. Yeah, this is about the base. And let's check the center of gravity. The center of gravity falls outside the base. Also, we can see the center of gravity falls outside. Same as this woman, the center of gravity falls outside the base of the object. Yeah, why it become unstable when the center of gravity falls outside? Yeah, who can explain why it become unstable when the center of gravity falls outside the base? Because the moment, yeah, it can be turned clockwise or anti-clockwise. Yeah, yeah, it causes the object to turning effects or a moment. Yeah, it can be clockwise or anti-clockwise to make it stable. Yeah, go back into its positions to make it more stable. All of the object weight, yeah, can be considered as acting through the center of gravity. If this act outside the base, then it will cause a turning effect or a moment. Yeah, it can be like this. Turning effects. Okay. And then, yeah, for example, the traffic count, yeah, is a great example of a very stable object. Yeah, this is the traffic count. Yeah, what do you think about this traffic count? Why? It is an example of very stable object. What do you think? What do you think about the base and center of gravity? This is the center of gravity. What do you think? What are the characteristics of base and center of gravity? Because the base, yeah, wide, and the center of gravity very low. This is the position of center of gravity, very low. And wide base. It's why the traffic cones, yeah, very stable object. Yeah, low center of gravity and wide base. Okay, go back to our starter questions, yeah. Can you arrange it from the most stable until the less stable?
B,
D. Okay.
B,
Next. B.
A,
uh,
C.
A. And
C.
last. C. Okay, correct, yeah. You get the point. Yeah, so, yeah, to make it stable, yeah, make the base wide and then make the center of gravity lower. This is the lowest center gravity. This is the highest. But, yeah, we can see this woman, how about the shoes from the woman's? The area, this is the surface area. The Batman is wider than the base of the woman's. It's why A and C. Yeah, hence, to increase the stability of object, center of gravity is as low as possible, and then make sure the area of its base is as wide as possible. Yeah, it's why all racing cars have very low wide base and low center of gravity because it's the most stable. Hmm, the most stable. And a more stable car, the faster it can go around tunes without overtuning. Yeah, it's why more stable means more faster the car. Okay, then yeah. Do you have any question, dear students, about the stability?
No.
No. Yeah, this about the stability. Yeah, this is the relationship between the center of gravity and stability. Lower the center of gravity, yeah, higher the increase the stability. Wider the base, okay, it's also increase the stability. Yeah, it's why.